Alright, number 27, on this page, a few problems solving for the variables using our similarity ratios and proportions. So, let's just go for it. 27, to find x, you see that x corresponds with 42, so x should be 42. Again, they're telling us that the figures are similar, so we don't have to think about it. We can see for y, it should go with this angle. Okay, it should add up 360 because there's 4 sides. And so we got 90 plus 90, 180, plus 42, 222. 360 minus 222 gives the rest of that, which is 138. So y is 138 degrees. Okay, and for z, 12 over z, corresponding sides, should be the same as 8 over 6. So cross multiply, 8z equals 72, and z equals 9. For number 28, if we drew this out, okay, just redrew our triangles. What we have, 10 is the hypotenuse, 6 is the short leg, hypotenuse short. For this one we have x minus 6 is here. We don't know anything else. And then our original triangle, this hypotenuse would just be x, and this short leg would be 10. So looks like we're stuck with hypotenuse short, and so the middle triangle doesn't really help us at all. So our proportion, hypotenuse over short, 10 over 6, hypotenuse short, x over 10, cross multiply, 6x equals 100. Divide by 6, and we get x equals 50 over 3. If you want to do 16 2/3. Not a pretty number, but that's what it is. Number 29, trying to find x, trying to find y. Again, they tell us that these figures are similar, so we don't have to think about it. Notice that x corresponds with 8. It's on the side of the 90 and the congruent angle. So x over 8. And then 9 corresponds with 6. Cross multiply, 6x equals 72. So x is 12. For y, it's the hypotenuse, and you might say, well, they didn't even give us a value. How are we supposed to do this? Well, it's a right triangle, so we can use Pythagorean's theorem. 9 squared plus 12 squared equals x squared, or y squared in this case. 81 plus 144 equals y squared. That's 225. Take the square root to find out what y is. That's 5 times 45. That's 9 times 5. 3 and 3. Hey, a pair of 5s, a pair of 3s is just 15. For 30, we have the similarity in right triangles, the altitude drawn to the hypotenuse, so we're going to redraw our triangles and label those sides. So I have triangle here, x is the hypotenuse, 9 is the short leg, and y as our long leg. This triangle here, y as our short leg, 16 as our long leg, and z as our hypotenuse. And then the original triangle, 25 as our hypotenuse, x as our short leg, z as our long leg. Okay, so as I look for x, I see that x is the hypotenuse and the short. So I can solve that using hypotenuse over short, x over 9, hypotenuse over short, 25 over x. Cross multiply, x squared is 225. It means x has to be 15. Okay. With y is the long side and the short side. Long side in this triangle, short side in this triangle, so long over short. Y over 9. Long over short, 16 over y. Cross multiply, y squared is 144. And so that means y must be 12. Then as we look at z, z is the hypotenuse on the long side, hypotenuse in this triangle, long side in this triangle. So we'll set up with that as our ratio, hypotenuse over long, z over 16 equals hypotenuse over long, 25 over z. Cross multiply that, 25 times 16, 400. So z squared is 400. Must mean that z is 20. Okay, so the next problem, 31, a little less involved here, really. Side splitter corollary. Okay, if it works in a triangle, it must work with these lines as well. Cross multiply, 77 equals 14x. Divide both sides by 14. And we should get 5.5. 32, another similarity in right triangles. So again, I'm going to, well, actually I'm going to use the shortcut here. It makes it a little bit faster. So if you're using that, we see that x should be the geometric mean between the side closest to it and its entire hypotenuse. So x is the geometric mean between the side closest to it, 6, and the entire hypotenuse, 14. Cross multiply, x squared equals 84. X squared to 84. What's that? 4 and 21. So we should get 2 radical 21. Okay. For y is the geometric mean between the two segments of the hypotenuse. So y is the geometric mean between 6 and 8. So y squared equals 48. That's 16 times 3. And so we should get 4 radical 3. And then z should be the geometric mean between the leg closest to it and the entire hypotenuse. So I said leg, the segment of the hypotenuse closest to it. 8, the entire thing is 14. Cross multiply, it's 112. So z squared equals 112. Square root of that, what do we get? 16 going here. Yep, great. 16 times 7. 7's prime. 16 we know break down to 4 and 4. So 4 radical 7. Alright, moving to some next problems. Got another similarity in right triangles problem here. If you use Pythagorean theorem, I'm not going to. I'm going to use the geometric mean shortcut again. 4 is the geometric mean between the segment closest to it, 2, and the entire thing. So I can write that as 4 is the geometric mean between the segment closest to it, 2, and the entire thing. We can write this entire thing as y plus 2. Okay, so we can cross multiply now. 16 equals 2y plus 4.
12 equals 2y, y then equals 6. Okay. Now that we know that y is 6, it'll make finding x that much easier because x is the geometric mean between these two numbers, 2 and 6. So x is the geometric mean between 6 and 2. Cross multiply, x squared equals 12. Take the square root. That's 4 and 3, 2 radical 3. And then z is the geometric mean between the segment closest to it and the entire hypotenuse, or the segment of the hypotenuse closest to it and the entire hypotenuse. I should say that. So z, the geometric mean between the segment of the hypotenuse closest to it and the entire hypotenuse. So z squared is 48, and that will give us 4 radical 3. Number 34, they tell us that the figures are similar, so there's no need to try to prove it or anything. We should find out our our similarity ratio by finding our corresponding sides. So 10 seems to correspond with 5, okay, and we know both those values, so it should be a 1 to 2 ratio, okay. So our similarity ratio is 1 to 2. All right, so we'll use that now to solve all these. So to find x, we do 10 over x, cross multiply, all that jazz. We should find that x is 20. To find y, it corresponds with 35. So 1 over 2 equals plot over 35. Okay, making sure we put y on the top because y is from the smaller figure. So 2y equals 35. That means y must be 17.5. And then z corresponds with 15, still the same ratio, 1 to 2. Z is from the small figure, goes up top, 15 is from the large figure on the bottom. So 2z equals 15, z equals 7.5. Okay. To find x, we can look at that side split. This is the side splitter theorem. Notice that there the x is on the side that we don't know, or sorry, that's being split, and so we can use x over 13 minus x equals 2 over 3. Okay, cross multiply, 3x equals 26 minus 2x. Right, yep. Alright, add 2x to both sides. 5x equals 26, and that means x will equal 5.2. Okay. Then underneath here we have 36. This looks like a side splitter problem, like with 35, but notice that x is not on the side that's being split, so we can't set up the proportion as easily. Probably be best to redraw these similar triangles. Here, notice that they're similar because we have this shared angle here and these corresponding angles that are congruent because of the parallel lines. So angle-angle similarity. This is 6, this is 9 for our larger triangle. This is 8, this is x. So we can do 6 over 8 should be the same as 9 over x. Simplify 3/4 if you'd like to. So 6x equals 72, and that must mean x is 12. For 37, we have the triangle angle bisector theorem. X over 40. Remember, this angle bisector separates the side that intersects, and the same ratio separates the sides of the triangle. So x over 40 should be the same as 15 over 16. Cross multiply, 400, 600 equals 16x. I want to think 50, but no, it can't be. What is it? 600 divided by 16, 37.5. And that's why we have calculators. And then finally, another side splitter problem here. Notice that x is on the side that's being split, so we do not have to redraw our two triangles. We can if we want to, but we don't have to. So 12 over 30 equals x over 2x plus 10. Okay, you could simplify this if you wanted to and use it as, what is that? 6 over 15, 2 over 5. Yeah, 2/5. Okay, so I'm going to use 2/5. Cross multiply. 4x plus 20 equals 5x. So subtract 4x from both sides. X equals 20. Alright.